So we have less and less billion. Why? Simply because we put in the 2 quizzes. So the quiz is stimulating the exam. So if you fail the quiz very badly, means your exam also is gone. So it's a wake-up call. So I think after I do this, the passing rate increase. Because if your quiz do badly, you still got a few weeks to back up, practice for the exam. Also, I urge you, ACTA, DCTA, and PEA, all these have exam. So you must really spend time this semester. If you are working, if you are very busy, please make sure you take leave before exam to study. It's not like last semester where there's no exam, you can last minute project work pass. Or honeymoon is over. Last semester is honeymoon. 上个学期是度蜜月，这个学期是很辛苦的。So I hope you spend time because there's many students who fail past semester. They fail ACTA. They will also fail DCTA. They may also fail PEA. So PEA is a bit easy, but AC, TA, and DCTA most likely will fail both. Because these are the 2 subjects you need a lot of practice. So you tell yourself, after today's lecture, practice. Every time you practice, by the time exam, you should be okay. If you wait until exam then practice, sorry, unlikely you can clear. I will see you next semester. Every semester got this module. Yeah, so I hope the next lecture will be smoother. All the QR code, you know where to scan. Yeah, and if you cannot scan this sign, at least Mr. Cole can manually update the system that you are in today. So you do counting also. So we try to minimize all this process to focus to the lecture. Next thing is I'll be setting up a WhatsApp group for Mr. Cole. So if you got any question, you can put in the WhatsApp group after the class. You try his best to reply. Or not, you send an email. Yeah, thank you.
Okay, the WhatsApp group actually is for the purpose of the WhatsApp group is for group learning. Why I say so? Because if you don't know, doesn't mean that other people know. All right. So if you ask a question, it may be a very simple question. You may think it's very stupid, but never mind, just ask. Whenever I answer you, and you'll benefit all the rest of the students. Okay, all right. So that's the purpose of the WhatsApp group. So don't be different class.
So there will be 3 WhatsApp group.
4. No, 3.
3.
So Farhan, you will have to join my class WhatsApp group. Okay, fine. So okay, so 3 WhatsApp group basically. That's why you see the QR code. The 2 top QR code belong to my class. All right. That means EE1A and EEC2A. Then the bottom left is Mr. Young's class. Then the bottom right is Mr. Bernard's class. Okay, right.
So automatic next week, just scan for my class, scan this one.
Yeah. Okay.
Mr. Young one here.
Young or Young?
Yeah, YAM.
YAM is
Young thing.
Yeah, Young saying the Young. So Mr. Young one is bottom left. All right. Then for my class one, both on the top. Okay, all right. So I arrange it this way. So every time you come here, you don't need to ask me anymore. Okay, all right. So we take some time to do this for admin because today is the first lesson. So I hope, so can y'all, I think Mr. Bernard has already briefed you all on the class. So can y'all take a picture of this? All right, everybody take a picture of this.
It's the lesson plan.
The lesson plan that I recreated. All right, so, okay, I think it's in the okay, so can you refer to that? All right, so then you follow that lesson plan. The second column shows all the lectures. So all the lectures will be held here. So don't go anywhere. Okay, all right. So A class, just don't remember. Lecture must be there. Don't go to block 50. All right. Then the third column is a tutorial. Tutorial is at block 50. Okay, all right. Then the fourth column is only one lab class. The lab location is block 8. Okay, it's given there. So you just follow accordingly. Okay. By that time, I will give you another briefing. Okay, all right. So assessment, I think I don't need to cover already. You all know already. So the assessment is based on this. It's also inside there. Okay, all right. It's inside the lesson plan. Okay, all right. Okay, so thank you for that. Okay. Anybody feeling hot? Because I think the aircon is not very cold here. Okay, so all right. So let me start. Who didn't sign the hard copy? Anybody didn't sign the hard copy? Let me just ask for the name. Nasra Fikri. Yeah. So Muhammad Syazwan. Yeah. Okay. So these are the two students. Okay. All right. Okay. Thank you. All right. Okay. So without further ado, can I ask some of you to log into Team and see whether you can hear my voice. All right. Microsoft Teams. All right. Because I'm doing a recording for this lecture. All right. So you can see that the recording has started. So you see whether you can hear me and also can see my screen. Okay. So can you all take note? If my red border here, can you see the red border here? Outlining the whole screen. If this border disappear, let me know. Raise your hand quickly. Okay. Because that means I didn't share the screen. Okay. If I didn't share the screen, I only recording voice only. No video. Okay. All right. So this is something I want you all to help me to take note. All right. In case something happened and I accidentally press off the screen sharing. Okay. Okay. Good. I see somebody join the lesson. All right. Okay. All right. Okay. So let me see here. So I admit all. Okay. All right. So can you try? Abdul Majid. Yeah. Okay. Try. Can you hear me? Can you hear me? Can you see the screen? Okay. Can you see the screen? Okay. Good. Okay. All right. So I just admit all those who are here. All right. Okay. And please off your mic. Yeah. Okay. Off your microphone. Right. Okay. You can hear? Okay. Very good. Thank you. All right. Okay, so please don't do anything to the screen. All right, I already started the recording. And please off your microphone. Muhammad Azuddin, off the microphone. All right. Yang Piao also off your microphone. All right. Okay. Thank you. All right. Okay, so let me start. Okay, all right. Okay, so for this lesson, all right, I think somebody still haven't off the mic. Yeah. Okay, please off the mic. Okay. All right. So let me start. Okay, so I'm going to cover something here. All right. Okay, is somebody off your mic? I think your mic is still on. All right, because I'm hearing feedback on the noise. Okay. All right. Okay, so let's start. All right. Okay. So the first thing that you need to know is that you have to know what calculator I use for the exam. So can you turn on to the hard copy that I give you just now? Can you take out and see the calculator required? All right. It is also here. All right. Okay, so there are a few calculators that are required for you to use for the exam. All right. So the one of them is this one. All right. FX991EX. All right. I think somebody still didn't off the mic. Can you help me to off the mic? Whose mic still on?
Mine is on.
David Das, off your mic, please. Yeah. David Das. David Das, can you off your microphone? It's slow. David Das, where is David Das?
Yeah.
Can you off your microphone? You don't need to speak to me because you are here, okay? All right, can you off your mic? David Das, you don't know how to off your mic. Hello, David Das.
Yes. Here, he's trying to off.
But you cannot off your mic.
Oh, I never muted.
Just click it mute lah. Mute it, you off. Either that you disconnect and go out. Because it's disturbing my lecture. All right. Okay, thank you. Can you exit then? Leave the classroom? Yeah. Leave the classroom? Okay. All right. Okay. Maybe just never go out yet. Go out, get out of the classroom. Yeah, just leave the classroom, yeah, because it's recorded, don't worry, it's recorded. Whether you're there or not there, you still can hear. You still can see, okay? All right. So can you just leave the classroom? Now you off the mic already. You see now got no feedback already. Okay, very good. All right, okay. So every time you go in, please off your mic if you want. If you don't want, then please don't join the classroom. All right, it's still recorded, okay? All right, so let me show you what are the calculator for the. Okay, so this is the first one. Okay, why we recommend these three calculator? The next one is FX991ES. Is because of the large display. Let me explain. This large display can show 3 lines of information. So this 3 lines of information is required when you do complex number calculation. Okay, all right. Otherwise, you cannot see 3 lines, means you will not be able to display correctly and you got to do a lot of manipulation to your calculator. Last but not least is this calculator is your 570ES plus. Okay, all right. So these 3 calculators either you can buy online. It's about between $15 to $25. All right, I purposely didn't show the price here. All right, I removed the price here. Or if you want, you can go to Mustafa to buy. All right, okay, it's your choice. Okay, all right. So anybody got any questions? All right, try to get one of the calculators recommended here, which is also given to you. Okay, so so before I start, I want to do a short introduction to this, which I did not give you the paper. All right, I want you to show you what is the meaning of this we call prefixes. Okay, all right. Prefixes. Okay, if you want to take a picture, you can take a picture of this. All right. What's the meaning of prefix? Prefix means when we talk about units, we got different types of units. We got hundred, thousands, mega. Mega is also mega is million, right? Or giga. Giga, I think everybody very familiar. Gigabyte. Every time you say buy your phone, how many gigabyte? So you're very familiar. Then the TB also very familiar. Terabyte. But then when you come to a smaller number, you got milli, micro, nano, pico, etc. All right. Who on the mic? Can you off the mic again? Who is on the mic? Because it actually disturbs the recording and it's being recorded into the lecture. Okay, all right. Although you can't hear, I'm hearing it. Okay, all right. So please on your mic. Okay. All right. Next one is centi, milli, micro, nano, pico. All right. So these are the common use one, which is your milli, which is 1/1000. Micro, we use it for capacitor, microfarad, 1 million. That means 1/6, 1 million. 1 divided by 1 million. Then nano is 1 divided by 1 billion. Then 1 pico is 1 divided by 1 tera. Tera is 10 to the power 12. So therefore, you take 1 divided by 10 to the power 12. You get 10 to the power of minus 12. So this one becomes 1 trillion. All right. So normally these are the units that we use, including the one on top, which we use mega, giga, kilo. All right. So these are the commonly used one. So let me zoom out. I want you to take a picture of it. All right. Can you take a picture of this? Okay, taken. Okay, take a picture of this. All right. So this one I didn't give you. All right. Okay. Somebody still on the mic. Yeah. So can you off your mic? All right. Okay, let's continue. So now I give you some example. All right. Milli is. Can somebody off the microphone? I don't want to say who because I can see from here who didn't off the mic. Who didn't off the mic?
Then Muhammad Fauzi. I can tell you who I can see, okay? Please off your mic. So don't let me point you out, okay? All right. Okay, so please continue. Let me continue. All right. So let me give an example. Let's say I got 1 microfarad. I want to convert to how many nanofarad? How to convert? Tell me. Sorry. Yeah, so if I want to convert 1 microfarad to 1 nanofarad, how many nanofarad? What is the conversion? So then you know that this is 10 to the power of -6. This is 10 to the power of -9. So then how do you convert? Tell me. Hello, can I have a show? How do you convert? Which one divide by which one? Left divide by right or right divide by left? Huh? So what's the answer? Tell me the answer. 1 microfarad equal to how many nanofarad? How many? Don't know how to divide. What do you do? You don't know how to divide. This value is -6, right? Hello, micro is -6. All right. This is this one. Then the nano is this one. All right. Nano is this one. All right. So then how do you convert? Can convert or not? Know how to convert? Anybody know the answer? How many? Why 1,000? Tell me. Yeah, like times 3 0 lah, but why? Because which one bigger? Let me ask you. Micro bigger, right? So therefore, because the difference is by 1,000, why? Because one is -6, one is -9, so the difference by 1,000, so therefore is 1,000 nanofarad. Okay, very simple. Actually, you just do this. 10 to the power -6 divided by 10 to the power -9. Okay, all right. So therefore, you get 1,000. So the answer here is 1,000. So all this you must know how to do the conversion. Okay, all right. All right. So there's a very common factor that common way that we always ask you to do in the exam is to take milli divide by micro. Okay, you tell me what is the factor here. So equal to how much? Okay, milli is -3, micro is -6. So what's the answer? Hello, what's the answer? Hello, what's the answer? Milli, look at the one. Milli on top there. Milli is -3. Then micro is -6. So what's the answer? 1,000 also, right? Very good. Thank you. All right. Then the next one is, all right. How do we convert 0.1 mm? We normally use SI units. We must convert this to meter. So what's the answer? How do you convert? How do you convert from mm? Mm is milliliter. All right, millimeter. Sorry. M, the milli. This is the milli. Millimeter. Mm. All right. How many meter? Okay. So the easiest way I teach you, everybody learn this way. All right. Is to convert by moving. When you convert millimeter mm to meter, you just move the decimal points 3 times. Then put the decimal point here. In between, you add 0. Okay. And some students write like that. Equal to. Okay, is this correct? How many zeros should there be? 3. Very good. So you can see, if you do this, this is wrong. Why? Because he forgotten 1 0. This is wrong. So he's forgotten to put 1 more 0 because after the decimal point here, got 1, 2, 3 0. All right. So therefore you get 0.0001. Okay. All right. Okay. So you must know how to convert this one. This is the most important, most of the significant importance in conversion of units. So if you know how to do this correctly, you should be able to get it correct. Another conversion is millimeter square. So your area is given in mm square. let's say given as 50 millimeter square. So I want to convert to standard SI unit, I must convert to meter square. So what's the answer? Hello, what's the answer? 50 mm square, I want to convert to meter square. How to convert, everybody? Mm is 10 to the power of -3 meter, right? Correct now. So you -3. So how many -3 you times? Times again one more time, right? Because it's meter times millimeter, right? When I say mm square means like this. When I say mm square means I take mm times mm. Okay, then this one is meter times meter. All right. So when I want to convert mm to meter square, millimeter square to meter square, I have to, this 1 mm is -3 meter. This 1 mm also -3 meter. Okay, so you multiply them, go together, become what? -6, right? So therefore, in this case, you have to move the decimal point. Let me just move this a bit. Oops, sorry. Okay, wait, let me move this. Okay, and move this one to the side. You cannot. So, okay, so if you want to do this, you actually can move the you can move the decimal point to the left because it's -6. These two multiplied together, you get 10 to the power -6. So you move the decimal point 6 times to the left. Okay, so that means you will get this. Decimal point is here 1, 2, 3, 4, 5, 6. So this is my new decimal point. In between, you add the 0. Okay, so your answer becomes 0.00405. Okay, so this is how you do the conversion. Okay, all right. So you must know how to do this by heart. I cannot tell you how to do because this is part of the exam question. Exam question will say, oh, my area is given in 50 mm square. But the calculation, you need to convert to meter square. That means the right-hand side one. You must convert to meter square for calculation. You must convert this to meter square for calculation. This one, right? For purpose of calculation. If you don't know how to convert, then you get the wrong answer. Okay, right. Okay, so far, anybody got any questions? Right, if no question, I'm going to proceed with today's topic. So can everybody take out the notes if you have that I've given you? Otherwise, please take out your own book and write the answers on the book. Okay, all right. So today I'll be going through this one. So please go through this one with you. So today lecture is on 22nd of October, 2025. I'm giving the lecture class to ACTA. Okay, there are 5 classes, including one. So altogether there are 49 students. All of you are 49 students here. Okay, right. Okay, so let me start. All right. Okay. Everybody got this page? Everybody on this page, okay. So first, let me introduce the concept of charge. Okay, electric flux lines and flux density. Okay, so when there's a positive charge, this is called a charge. That means when we represent electricity, we represent by what we call in this case, it's like the definition of charge is like a ball like that. Right. So when this ball has a charge, all right, whether it's 1 coulomb or 2 coulomb, all right, you will radiate out electric field lines, okay, or what we call electric flux line. Okay, and this flux line is actually going out from the plus. So when we have a positive charge, it goes around, is flowing out. Okay, it comes out from the charge. If it's negatively charged, it goes in. Okay, sorry. Okay, it goes inside. All right, it goes in. All right, it flows inside. That That means it's like being attracted like that. All right. So what happened is this. So when they say the electric flux lines, in this case, will radiate out. Okay, radiate out. Okay, then from a positive charge. Okay. Then for a negative charge, all right, it actually terminate on it. Sorry, for a negative charge. For a negative charge, okay, the electric flux lines terminate. Like absorbing the energy like that, it terminate into it. Okay. So then if you got two positive charge, it doesn't meet each other because both are going out. So you notice that, oh, look at the diagram there. They actually repel. All right. So that means if you have like charges, it will repel. All right. Then if you got one plus and one minus, like a boy and a girl, right? Then you will attract each other. Right. So unlike charges attract. Okay. Right. So this is the definition of what a charge is all about. Okay. Right. If you have a positive charge, it will radiate out electric flux line. If it's a negative charge, it will terminate at the charge. So the symbol used is Q, and the unit is in coulombs, all right, and it's written as C. So what happened is that this C, later you may confuse with capacitance, okay, all right. So this is units is written on the right hand side, okay, all right. Whereas the charge Q is written on the left hand side. So the flux density, all right, D is defined by Q divided by A. Okay, so the A is actually what we call surface area. Okay, why surface area? Because when the energy radiate out, all right, it actually forms like a ball like that. Okay, so when you want to find the density, then you got to divide by what we call the surface area. I think you all may not know what is the total surface area of a sphere. Okay, a ball. What's the surface area of a ball? Or who keep football one? Oh, some of you keep football, right? What's the area of the ball? Not the volume, area. The outside area of the ball. What's the area? I don't know. There's a formula for that. It's 4 pi r square, not pi r square. It's 4 pi r square. Okay. So to find the electric flux density, we take the charge divided by the surface area. So therefore, the unit is C coulomb divided by meter squared. Okay. C over m squared. Okay. Right. So a simple illustration here. This is my Q. This is my area. Right. Look at the unit. Meter squared. So therefore the D is 16 divided by 4. So you get 4 coulomb per meter squared. Okay. So this is the most simplest calculation. All right. Okay, so why we need to learn charge? Because a capacitor is full of charges. All right. So that means when we charge up a capacitor, the capacitor has what we call an electric charge. Okay. How can it be formed? Okay, it is done this way. Okay. All right. So see the next page. Right. So this capacitor is what we call an electrical device to store what type of energy? Capacitor, right? It's an electrical device. So for what type of energy? Electric energy. All right. So therefore it stores electric energy. All right. Electric energy. Okay. And the figure represented there, put A and B. So this represents what we call a capacitor. Okay. With two parallel plate. Okay. Okay, so a capacitor is very easy to make. Just put two plates and it become a capacitor. Okay, all right. So you say, hey, teacher, very impractical, right? How to put two plates and become a capacitor? Later I show you the actual capacitor. It's not using two plates. Yeah, it will be used in a different way. So if you look at this, plate A on top has what we call positive charges. Plate B has negative. Quite straightforward, in this case. All right. Then if there is no battery, all right, it means this side, let's say this side, when there's no battery here, the capacitor is what we call discharged. So that means it's not charged at all. So the symbol, this is the symbol for the capacitor, by the way. It's a symbol, right, for capacitor. Okay, so when I draw a capacitor, I draw two parallel lines, all right. Then if there is no charge, therefore your voltage also 0. Okay, all right. So now what happened when we charge the capacitor? So to charge the capacitor, we need to add a battery. All right. A battery is one line long, one line short. Not the same length. Right. So let's say this battery got 10 volt. Right. So what happened is that when we apply a 10 volt here, the electrons from the top plate of the capacitor, that means the electrons here. Sorry. Okay, the electrons here, electron is minus. Okay. In the world, it's all made out of positive and negative. Right. One is called positive electron, one is negative electron. Right. So this negative electron will be attracted to the positive plate. You'll flow in the wire, by the way, flow in the wire, then flow all the way back to here because it's attracted. This side is the positive, this side is the negative. So as the electron leave, okay, as the electron leave the plate, sorry, let me just redraw again. As the electron leave the plate, you only left the positive ion there, right? So as more and more electron leave the top plate, therefore the top plate become positively charged. Okay, all right. So this is what is happening in the capacitor. All right. When I have a capacitor that is positively charged, it depends on the voltage direction. All right. So in this case, my battery is plus on top, minus below. So you can put plus on top, minus below. The top plate become positively charged. The bottom plate of the capacitor become negatively charged. What I'm referring to is here. This is the top plate of the capacitor. This is the bottom plate of the capacitor. Okay, right. So as electrons move away, top become plus. So therefore it attract the bottom to be a negative. Okay, right. So therefore you got a positive plate. So the top plate become positive like that. Right. Then the bottom become negative. Okay, let me zoom in. So that means the top plate of the capacitor become plus and the bottom become minus. Okay, right. So this is how the charges are formed on the capacitor. Okay, right. So what happens is that when you keep on charging, all right, then there'll be a time whereby your capacitor become fully charged. So when it's fully charged, that means this voltage here is become 10 volt. Then when all the electrons being attracted by the battery already, no more already, right? So there'll be no more current. So therefore, it will become 10 volt. All right. Why? Because no more electron can flow. So therefore, the voltage of the battery, sorry, voltage of the capacitor become the voltage of the battery. All right. So become 10 volt. Because if this is 10 volt and this is 10 volt, no current can flow. All right. Battery 10 volt, capacitor also 10 volt, therefore the current become 0. Okay, that means the capacitor now is in what we call a fully charged condition. Okay, right. So when the charge increases, when the charge on the capacitor increases, all right, the voltage of the capacitor increases. This voltage is on the capacitor, we call VC. Okay, please write the acronym there, VC. Right. So this is the voltage across the capacitor. Okay, I write short form, capacitor. Okay. So when the charge increases, the voltage of the capacitor increases. Okay, right. Okay, so now we come on to another new concept, all right, which is called electrical field strength. All right, that means whenever I apply a voltage across two plates, all right, we have something what we call electrical field strength. All right, that means this electrical field strength is the energy, there's a tension between the two plates. All right, so why is there tension? Because you apply a voltage across it. So if your voltage is so high, then what we call it a breakdown of insulation. All right, similarly to what you see lightning strike Earth. Okay, why lightning can strike the Earth? Anybody know? Why? Why lightning can strike the Earth? Do you know why? And lightning is caused by what? Lightning is also caused by what we call electrical charge. All right. So when there is a lightning form, how the lightning form is like this. The Earth is actually normally positively charged. And when the clouds are moving, right, they rub against each other. Then it causes what? When you rub, what happens? It loses all the positive ion. Then it becomes negatively charged. So if this negatively charged become very, very strong and very powerful, become very high, the value become very high, that means very strong charge. Then you attract the Earth. The Earth become what? Negative on top, bottom become what? Positive, right? So this one will attract. The negative charge is so strong, so you attract the Earth become positively charged. Then what happens? When it becomes so strong, so powerful, yeah, strike. So the lightning strike, then it causes a discharge. Straight away it discharge. Hey, wait, wait for the next time. Rub some more. Bam, one more time. So this is how lightning strike the Earth. Okay. Why is there lightning? Lightning is also because of electrical charges. Okay. Right. Not because of anything else. They say, hey, how come lightning strike here? Don't strike anywhere else. You choose for the what? Weakest part. Okay. So if you carry umbrella, you're wet. If your impedance is low and you are below a tall tree, especially if it's wet and raining, then what happens? If that tree happens to be the weakest point, then lightning will just But I always have a good saying, my professor tell me, he say lightning got eyes. Normally they don't strike people. Very surprising. So you can see in the whole world, not just Singapore, how many people has been struck by lightning before and get killed? Very, very rare. Right? So somehow lightning know, oh, we got people there, I don't strike you. Not true. Just kidding. Right? Okay, let's continue. All right. So let's continue this one. Okay, so an electric field is formed. All right. So the word to you right here is called an electric field. All right. So this electric field is formed. All right. So when we have two plates on the capacitor being charged by a battery, okay? So then the electric field strength is determined by the following, all right? So it's written as this, but no need to write like that. Okay, it's actually E, you want to write a simple word, is E, but because we confuse E with the source voltage and all this, so there's a special symbol for electric field strength. So it's a voltage divided by the distance, okay? It means how close is your distance and how much voltage you apply. The V here, the voltage you apply here, this is my V, all right, will determine the electric field strength. So the unit is therefore volt per meter square, volt per meter, okay? All right. So if you have an electric fuse, a parallel plate of 200 volt, and this is facing is the D, all right? So therefore, your electric field strength is this. So E. So you can actually draw this triangle. E equal to voltage divided by D. Can you draw this triangle? All right. Put on the mic. Can you off the mic? Okay. So this voltage is 200. Then you divide by 0.8. What did I say? Mm, right? So what must you do? Convert to what? Convert to meter. Very good. So this is 0.08 mm. You must convert to meter. So you move the decimal place 3 times to the right, to the left, sorry. 1, 2, 3. Right. Then you write all the 0 here. So the answer should be how many? The answer is incorrect. So the answer should be 250 kilovolt per meter. Okay, or you write 250,000 volt per meter. Same answer. So this answer is wrong. Wrong answer. Okay, anybody got any questions? So this is how you find the electric field intensity. Okay, right. Okay, so to measure charge, we have something what we call a unit of the coulomb, all right, which is equivalent to how many million, billion electrons. Okay, so let me show you how many. Can anybody know 1 coulomb got how many electrons? 1 coulomb, don't know, right? Do an internet search. Okay, so if you do an internet search, let me show you. You do an internet search, all right. Yeah, Google AI will tell you, right? Okay. So that it shows there, right? One, wait, let me see. Okay, all right. There you see. 1 single coulomb of electric charge is equal to 6.25 around there, 6.24 times 10 to the power of 18 electrons. Okay. Just now you learn how many? You learn giga, tera, then don't know what, femto, all this, right? So this is how much is your. That's why you got the units here. That's why I say you still got the unit. 18. I think don't have. I don't have 18. Let me check. I see whether I got 18 or not. 10 to the power 18. I got. EXA. I never heard this before. So. You can see it out there. 18, 10 to the power 18, EXA. It's actually billion. No, giga times giga, or billion, same, right? Okay. So normally we don't use such a figure, but this is how big, or sorry, 1 coulomb equal to this number of electrons. So you cannot imagine so many. So it's actually 6.24. So if you reverse it, you take 1 divide by this one, you get approximately 1.6 times 10 to the power of minus 19 coulomb, right? Okay. So 1 electron got a very small charge. Okay, right. Okay, so if a capacitor is connected to a battery, all right, we have what we call a relationship between the charge and the voltage, okay? And its relation to what we call, what is the capacitance of the capacitor, okay? All right, so if we want, we have 8 coulombs here, all right? We have a voltage of 2 volts, all right? So the voltage of the capacitor is 2 volts. The charge stored is 8 coulomb. So the storing ability, all right, because charge is an energy, all right. So therefore, you will be 8 divided by 2. How much it can store in 1 voltage, all right. So therefore, this is 4 coulomb per volt. Okay, that means this 4 coulomb per volt is how much charge it can store in 1 volt. right? That means this is how what we call the storage capacity of the capacitor. Okay, right? So now we do the another way. If this same capacitor, now I change the battery source to become 5 volt, then the charge stored on the capacitor increases. Okay, all right. So if I put voltage of capacitor now is 5 volt, right? Then if I have the storing, sorry, my pen need to charge also. My pen got no charge. All right. You just explain a bit now, right? So if you have charge stored on the capacitor is 20 coulomb, and I have 20 coulomb of charge is stored in the capacitor, right? Then what is the charge storing capability? So it's in this case it's the same. So if you got 5 volts here, and now my charge storing capacitor is 20 coulomb, I write C or do. So when you write the unit, you write the first letter, capital, all right? So therefore become 20 divided by 5. So you look, it's the same. So it's 4 coulomb per volt. Okay, all right. So this is the definition of the capacitance, right? That means if I put the same capacitor and I increase the voltage, the charge increases. Okay, all right. That means I can store more charge. Okay, the more charge it can store, the more electrical energy it can deliver. Okay, all right. So capacitor measures the capability or the ability of the capacitor to store charge. Okay, and this is the unit of this capacitance is therefore known as farad. Okay, or capital M. Okay, write the first letter. So you can say that C equal to Q divided by V. All right, just now we say, right, Q divided by V, this is the ability for the capacitor to store charge. Okay, so if we rearrange, then we bring the V to the left hand side, then Q becomes C times V, or V equal to Q divided by C. So we draw this triangle always, Q, C, and V. Okay. If we want to say V, example, we want to find V, all right, this one, all right. Then we just remove V, then we get Q over C, okay, all right. If we want to find Q, all right, we want to find Q here, then just remove Q, then you find that, oh, it's C times V, all right. So similarly, you want to find C, you get Q divided by V, okay. Q is the charge, V is the voltage, okay, all right. So this is how we define the unit of how you calculate the capacitance given the charge and the voltage, okay. Similarly, I draw an analogy to you. I think you all learned in physics, maybe last time, long ago. The voltage is I times R. But this is not voltage, resistance, and current. This is Q, C, and V. Q is your charge, C is your capacitance, V is the voltage. Okay, all right. So it's similar type of concept and relationship. Okay. Okay, so let me go through some example. You got a capacitor, 8 coulomb, 2 volt. This is what we have done just now. Right, so this is charge is 8C. Voltage is 2 volts. So capacitance is 8 divided by 2, which is Q over V. Right, so therefore you get 4 farad. Okay, example 2, 16 coulomb. Voltage is 2. So capacitance is 16 divided by 2. So therefore you get 8 farad. So you notice that example 2 is a bigger capacitor. Okay. Then you say, teacher, how big is a 1 farad capacitor? Go and find internet. Quite big, 1 farad capacitor. About like this, this thickness and about this size. Okay, quite big, Normally we don't use 1 farad capacitor. 1 farad capacitor very big, Let me show you internet. You can search. It's quite big, All right, 1 farad capacitor, quite big, Look at some images, all right. So you can see that this is the size of a 1 farad capacitor. Okay, very big, Look at the dimension, about 1 inch, and the thickness is about 1/4 inch. So this is the size of the capacitor. Normally we don't use so big capacitor. If capacitor so big, we can store a lot of energy, but we need a lot of voltage to feed the capacitor. Okay, that means you need more energy to feed the capacitor to produce the charge. Okay, all right. So normally we use a very small capacitor, not so big one. Okay, right. Okay, example 3, capacitor 3. So now you are given the capacitor value. This is the C value. This is capacitance. This is the voltage. All right. So ask you to find Q. All right. So therefore you write Q equal to CV, or you draw the triangle QCV. So capacitance given is 25 micro. This is 10 volt. All right. So let me teach you a trick. All right. The trick is what? Don't convert the 25 micro to the correct unit. Okay, you say, oh, micro, I know, 10 to the power minus 6. Then you get 0.000025. Then after that, you go and multiply. Then after that, you say, teacher, how to convert back? No need. So what you do? Right, so you know Q equal to CV. Charge, this is Q. Is C times V. So you take C is 25. So you write the micro here. All right. Listen, write the micro there. Times the 10 volt. Okay. So then when you write the answer, continue to write the micro there. Then you just take the two number multiply by each other. So therefore you get 250. That's the unit for capacitor charge. Coulomb, right? So you must write in full. Initially, when you don't know, please write the word in full. Why? Because it is also written as C, micro C. So is this C same as this C? Same or not? Same, right? But are they representing the same thing? No. All right. So the C that I wrote on the top there refers to the capacitance. The unit is in microfarad. The bottom C I wrote is on the right hand side. It represents the unit of charge, which is Coulomb. All right. So please bear this in mind. Let me repeat one more time. The C you see on top here, this one represents capacitance. Okay, why we write like that? That means we say that C equal to 25 microfarad. So the C is written on the left hand side. So this simple C, capital letter C, can mean different things if you write on different side of the equation. All right. If you write on the left side, it means capacitance. If you write on the right hand side, it means charge. All right. So it doesn't mean the same thing. So when you write down, when you learn, as you're learning, when you're initially learning, please try to write this in full. Okay, then you know that, oh, my C down here is the charge. It's referred to the Coulomb. So that's why I write micro Coulomb here. Okay, all right, let's continue. So capacitor 4, we are given the Coulomb. So this is my Q. This is my capacitance. All right, look this C. All right. Then ask to find the voltage. So if you follow the triangle here, voltage equal to Q divided by C. So let me write down the value, 24 microfarad. This one is 120 microcoulomb. Okay, so your voltage is Q divided by C. So 1, 2, no need to calculate the micro, because it cancel out. So you just write the unit there. All right. So you notice that, oh, because they are the same micro, so therefore cancel out. Okay. So that means you only just take the unit division. So its answer is straightforward. So therefore it's 5. Answer in farad. Okay. Okay. So the answer is 5. Sorry, 5 volt. Sorry. The voltage is 5 volts. Sorry. Okay. 120 microcoulomb divided by 24 microfarad. So therefore you get 5 volt. Okay. Right. So the 2.3, all right, is an example. All right. Okay. Okay, let me show you a practical capacitor. All right. A practical capacitor, it doesn't look like the one that you see as two parallel plate. Okay. So let me show you. Okay, so a capacitor is not normally a two plate. All right. You can see that it's not a two plate thing. All right. What it does is actually this. It is actually something like this. It's rolled onto a coil. Let me show you this. I like this picture. It shows very clearly. Right. So you can see, all right. So this is actually the inside of a capacitor. All right. Is it flat? Is it flat? All right. I say capacitor made of two parallel plate. Is this plate flat? No, right? It's coiled up. So this is to increase the area. So the more area you have, the larger the capacitor. All right. So then why is it coiled up? Because this is the most practical way to make a capacitor. But my two plate cannot short each other. All right. The two plate in between, I must put something in between. So what do I put? You can see, you can see that I put something in between the two plate. This is called the impregnated tissue separator between the foil. So I must put something to separate the two plates. So and then this plate normally is they actually soak in oil. So to increase the capacitance. Okay, that means the more it is soaked in oil, so as to make sure that the two plates don't short each other. Because once you apply a voltage, the plate can get shorted if they are too close. So to prevent shorting, all right, we actually put something in between and we put oil in between as a insulator. Okay, all right. So I think olden days, nowadays not so bad. You know all these light fitting that you see on top, actually inside got a capacitor long ago, more than 30 years ago. This inside light fitting has a capacitor. So sometimes the fireman will say, oh, electrical fire. Then when they investigate the fault, it actually is caused by the capacitor catching fire inside the light fitting. And then because the old
So when I say the recording stop here,
Oh ya, the team semua kita tak exit.
stop recording, then you automatically